Hello and welcome back. In last lecture we saw how we can use the query method of DynamoDB client to query our table or global secondary index using a primary and range key. Now in cases when we don't know the primary or range key, we can use a scan method to still filter out our items from a table or global secondary index. But scan operation is less efficient, right? Because scan always scans the entire table or a secondary index and then filters out the values based on the filter expression that you provide. So if you see the documentation for scan method, so AWS says that scan operation returns one or more items by accessing every item in a table or secondary index. So the important point to note here is it will access every item in the table. So if you have millions of items in the table, it will scan through all of them and then run the filter expression to filter your result out of those items. And that's why scan operation is always less efficient. So you should always use scan when you cannot use a query or get item method. So this will be your last resort while fetching items from the table. So in order to do that, you should always design the table so that the application use query instead of scan. So just plan your partition keys and range keys ahead in time if possible. If not, and if your application has already grown big, you can always create new global secondary indexes to run query on them. Now there are a few things that you should keep in mind while running query or scan operations on a table or global secondary index. Try to have distributed requests over a period of time with smaller sizes. So the more of the requests you do or spread over a period of time with the smaller sizes of payload going in and out, it will be more efficient. Right? If you go frequent requests in bursts, it's not as good. And of course, like if you do large requests, random large requests, and create spikes, or do a large scan operation with a very large table, these are bad way of doing query or scan over a table. So let's go back to our code base and try to create an example of scanning our table or global secondary index. But this time, as we are scanning, we are not going to use a primary or hash key to get our items. So the first thing we need to do as usual is to create a new endpoint. I'm going to just use the same endpoint we used for querying. Just going to copy it and change the name to scan this time. So under this endpoint we use the query method, and now we want to do a scan and get the same item out of the table when we run our post request. Let's rename this to scan as well. I'll put scan in the end here. It will be a post method once again, and we need the similar rules. Let's save it. So next we need to create the new method under user.js. I'm going to copy the previous method, rename it to scan. Everything else remains the same. We still get our payload from post body, and then we send it to our actual scan method under dynamodb.js file, and we are going to send the body and the table name, and everything else remains the same. Let's go to dynamodb.js file again. So parameters list that we send for scan method are almost similar to query method. We just need to take out the key condition expression because there are no keys. We don't know the keys, so we take this out and use just the filter expression. So I'm going to just copy the whole method paste it, rename it to scan, and export it. Now, as I said, we don't know the keys this time because we are using dynamodb.scan method, right? But we still send all the parameters. We send the table name, the index name, but this time we are doing the exact same filter but without key condition expression. I'm going to copy that expression here and place it under filter expression. So a scan method will scan all the items in the table under global secondary index and run the filter expression. Let's take this key condition expression out, and everything else remains the same. We still need to pass the values of created at, country, and first name like we did in query, and get the projection expression out. I'm again going to set return consumed capacity as total to get throughput that was consumed to run the scan method, and to get other details like how many items were scanned, etc. Now we have exported it here. We also need to import this new method in our user.js. Right, and we are calling it here. Great, everything looks good. Let me check my serverless YAML once again. We rename this. Let's change the description a bit. Okay, let's go to our CLI and deploy our new function. So I'm going to run deploy command once again. So here our deployment is complete, and we have our new endpoint. Let's copy it. I'm going to go to my Postman. So this is what we use in querying. I'm going to change it a little bit. I'm going to put India, Ankur. Let's put Canada here and run it. So when we did the querying, we got it scanned 2 items, the query command, and we got back 2 results, right? So it did not scan the whole table here, and capacity units consumed were 0.5. Now I want to duplicate this and test our new endpoint, which scans our table. Let's copy the new endpoint here. I'm going to save it, and now I'm sending the same JSON body. Let's copy this and paste it here and see how the results look like. So when we scan our table, we still got the 2 items, but this time it scanned our whole table. So that's the difference. So as the table size grows, we have thousands, 100,000 millions of items. The capacity units it consumes will keep on increasing, because it's going to scan all those millions of items and then run the filter to get just 2 items. So scan is good in case you want to get all the items from the table, but definitely not feasible if you want to filter out just 1 or 2 items or limited number of items out. So that's the difference between querying and scanning your table or secondary indexes. Thank you, and I will see you in the next lecture.